I thought I'd start with a very quick overview on my monitoring system. What I've got is I've got an EmonPi, and it's from a company called openenergymonitor.org. I'll put everything in the description below so you can have a read about it or visit the websites later on. Now, the product that I use is the EmonPi. It's pretty much an off-the-shelf, easy to use, plug in and away you go product, but it also has tons of flexibility, and it's everything that you need if you wanted to monitor your power, your solar and anything like that. Now the unit itself has inputs for up to 6 temperature sensors so that you can put around the house if you need to. You can obviously have wireless ones as well, but it also comes with 2 CT clamps, one to go around your inverter and the other one to go around the main grid or utility power that comes inside the house. And just out of the box, what it's got a local version that runs a web server that has the local version of Emon CMS, and you can use that locally, or you can export that data to the web-based version or the web-based version of Emon CMS. I think it's emoncms.org. Again, it'll be in the description below. But what it does, the way I use it is I have everything logged to the device, and then it exports everything online, and then I manipulate charts and graphs and other bits and pieces all online. Pretty much what that allows me to do is be anywhere and pick up my smartphone or log on through the web and be able to access any of the data, see it all nicely visualized, and it makes it really simple. The other advantage of using a product like this is that not only is it open sourced, and it's something that you can change and do anything you like too. You can change how the web server works. I've seen some really good dashboards that people have made, some really flash stuff. You can decide to go down that route. You can just use the basic standard versions. You can do whatever you like because it's a Raspberry Pi, and you can customize it as much as you like. The other advantages with it is that you can not only just monitor your power, you can monitor things like water tanks, temperatures around the house, temperatures outside, humidity, wind speed, anything you like, water flow, all those types of things, small little projects that people have done. It's all on the forums. You can look up designs and other bits and pieces. If you're really into DIY and electronics and bits and pieces, you can make up little circuits, and you can send all the information from the circuit. For example, the one I did that I use all the time is for monitoring my water tanks. So I've got a little ultrasonic sensor that fires down, hits the water and reflects back, and that tells me the tank level. What happens then is it sends that every 10 seconds or 30 seconds to my EmonPi. That EmonPi logs it, and then obviously it sends it off to the online version, in which case what I then do is I have different graphs and bits and pieces so that I can see how my water tanks are going, and everything is nice and simple, and you can do whatever you like with the data. You can build anything, and if you can send it wirelessly to it, you can log it. If you can log it, you can then manipulate it and make some graphs and make some nice dashboards and make things look quite cool. Or you can just use the very basic part or the very basic function of the EmonPi, which is just to monitor your grid and your solar usage. And it does obviously a very good job at that. Pretty much you get a snapshot of every 30 seconds. You can shorten it, you can lengthen it. I think you can make it as short as 10 seconds. So it's a very powerful little unit that you can do whatever you like to. Now, apart from obviously my water tanks, sending that information to the EmonPi, I've also got the BMS unit for the Powerwall that are also made to send all its data, like the voltage, the current, the current on each of the banks, as well as the watts and all those other bits and pieces. I think there's about 8 different functions or 8 different things that are sent off wirelessly to this EmonPi, and then this EmonPi is then logging it on a 30-second log, and then as well as sending it off so that I can draw some pretty graphs. So it just means that it's a kind of a product that you can do anything you like with, and you can just imagine, just look around the house about things that you might want to monitor, or you could monitor your aircon. You can do anything, and that's why I chose to use this kind of product. The other advantage with it is that while it's can be a little bit expensive to first buy, the product is I've had it for the last year. It's worked flawlessly the whole time, and I can't fault it. So pretty much, if you want a monitoring system that really works and that you can do anything you like with and to, then definitely have a look at this option. Now, what I'll do is I'll show you my dashboard that I've made that's in kind of development really, but as a bit of a demo for the DIY Powerwall, and how the batteries and how the voltages and how the current is all kind of graphed, as well as the utilization. So I'll show you that on the computer screen. So this is how the monitoring looks online. So I thought I'd just record the screen because that seemed to be the easiest way to do it. So this, I'll just give you a very quick idea about what this is you're seeing now. This is, each of these is the two banks of 5 kilowatt hours. The voltage across them is the same. The current is independent on the readings. So obviously we haven't got a third bank in here, so there's no current reading there. But we've got, this is what bank 1's current is, and this is what bank 2's current is. So obviously you can see the power going between the two banks of 5 kilowatt hours, so that's quite handy to know. It also means that if there's a fault with bank 2, you'll see the power coming from there going to here. So it's actually quite good because you could put an alarm in so that this got turned off. Anyway, things for later down the track. State of charge, this isn't up to date because I can't get the state of charge to be precise, so I've just kind of left it alone for now, but I'll come back to that later further in the project. Voltage, this is just hourly graphs, so not too much to show there. What I've done is I've broken things down a bit into 4 different sections. This is the grid tie inverter. It's going to turn on very shortly. It's 10 to 8 at night and it turns on at 8. So this is the grid tie inverter connected to the Powerwall. Obviously right now it's not doing anything, so this is only shows negative numbers, so power coming out of the Powerwall. This is the 3 green solar chargers connected, so this only shows positive power going into the Powerwall. Again, it's late, it's night time, so there's nothing there. House grid tie, 240 volts. It's dark, so this isn't doing much. And house usage, this is what we're using from the grid right now. 10 minutes time, this will be pretty much 0 as things get turned on, as the Powerwall turns on. It's just kind of changing. We're almost at the end of daylight savings, so so my time that I need to turn the Powerwall on obviously needs to be dropped down to 6 or 7 o'clock because it's getting darker much quicker. This graph here is a bit complicated, so I'll show you that in a second. If I go down, we've got the voltage graph. I'll show you that in a second. I've also got each of the current sensors independently shown here. So this is a bit confusing. It's quite interesting to know, but it's also a bit confusing because you're looking at them individually rather than together. But you can kind of see the trends between them, and they're kind of almost identical. In fact, I didn't pick up the right time there as I zoomed in, but you get the kind of point. It's easier to look at this actually from the watt scale because it's combined. If I come down a bit further, this is the watts. So if I pick a day, and I'll try and pick a day like this one where it's got a nice curve. In fact, yeah, let's go with the curve. And so if I just zoom in on this period here, in fact I'll zoom out a little bit. So what you've got here, just to kind of explain this graph a little bit, is you've got 0 being the Powerwall doing nothing. Then what happens is that the Powerwall turns on at night, the power comes out of the Powerwall, so we have a negative number. This is how much power we used, about 1,000 watts for a good hour or so, and then as things got turned off during the night, 1 o'clock in the morning, the power dropped to around 400 watts, 300 watts. That kind of stayed consistent throughout the night. Powerwall turns off at 8 o'clock in the morning, so you have a sharp drop back to 0. This is only showing the Powerwall, so it sits at 0 for a while until the sun comes up. The sun kind of comes up and we have a nice curve. This day was quite good. This day here was very cloudy, but again we kind of peaked at about 1100 around there maybe. It kind of came up 1300, 1700. Nothing much happened here because it was dark. Then the Powerwall turned on again automatically at 8 o'clock. Powerwall came on, and yeah, again this is the nighttime usage throughout the night, and then the whole thing repeats itself. So if I just zoom in on the nighttime usage between here and here, you'll see on this day I didn't remember what date it was, but either way it comes on. You see the nighttime usage, it's fairly accurate and it's quite good. So this is the watts coming from the Powerwall, not the watts that are on the inverter. So this is slightly higher than what's shown on the inverter, because obviously the inverter has isn't 100% efficient. So because of the efficiencies, the inverter will show a lower number than you can see here. So this is the higher number. This is the number you actually want to see, because this is the power that's actually coming out of the batteries. So that's quite good. Obviously I can zoom in on this all over again, and we can kind of keep zooming in, but we don't really need to see it in that accurate. But most of the time throughout the night it's about 200 watts, roughly 330 watts, 350 as the fridge and bits and pieces turns on. But that's all working really well, and that's fantastic having this monitoring all set up and working as it should. If I come back up to the voltage, this is kind of how things normally run. So if I look at the voltage from just the other night, and I'll grab this voltage here, we didn't fully charge, we only charged to 77.3 volts. So I'll just grab this day here as an example. So Powerwall turned on, the voltage dropped quite quickly when we pulled 1000 watts, and the voltage dropped slowly throughout the night to the point that we got to 7 o'clock or somewhere around there, and then eventually the voltage started to go back up again. And this is quite handy and quite interesting to watch, and this is the kind of the graph that I mainly use, as well as the watt graph down below. But as you see, you can kind of monitor what the voltage is doing. If we look at a day that I almost fully charged, then you'll see that the voltage, I'm trying to go a little bit quick so we're not having a really long video, but the voltage came down from 79 volts slowly down to 76 over the time, 1 o'clock in the morning, 75 volts, and then we kind of have a bit of a drop off. We ended up using a bit of power that night. I think I stayed on the computer quite late, so that's how that kind of graph looks. This graph up the top here, this is a little bit complicated graph, because this shows a little bit more detail on more things. So what this is really showing, this is today, and what this is showing is that the hope you don't run out of battery. No. So what this is showing is that the Powerwall here is not doing anything. There's no power coming out of the Powerwall, and then the red and the negative is what was coming from the Powerwall at night. And obviously the next thing is that the yellow here is the power we're using from the grid. So up until 8 o'clock at night we're using power from the grid, and as the Powerwall turns on, then we don't use any grid power, or almost no grid power, and the rest of it's coming from the Powerwall. So that's why the power coming from the grid, the yellow, is flatlined almost along here, and then obviously Powerwall turns off at 8 o'clock in the morning. There's not enough solar that day, so there's a slight bit of power use from the grid, and then obviously we start going into the minus from the main inverter on the house, and the blue is what's charging for the Powerwall. So if I just come out of that just very quickly, and I zoom out of this, and I go across a little bit more, then you'll kind of see what happens on different days. And this is probably a better day here to use as an example. So it wasn't very sunny at all this day. As you see, there's not much negative coming from the main house, the yellow, but when the Powerwall turned on, you have that nice drop from the not using any grid power to nothing, flatlined on the main grid power. But this is the Powerwall power coming from there, and then this next day is quite sunny, so the main part, we start exporting power, which is this. Solar starts charging the Powerwall, which is the blue, and during that time obviously there's the red flatline because there's no power coming out of the Powerwall. So this is a little bit more complicated graph to kind of wrap your head around in a quick little video, but having all this monitoring set up is just fantastic, and having it all on this website is just really great. The best graphs to use are the voltage graph. You can kind of see things taper off, and the watts in general. Obviously up here I can turn things off, so I can turn off just one of the three, and I can turn off different pieces. So that shows you the discharge, and then the charge, and then the discharge, and the charge. So thanks for watching, guys. Hope you enjoyed the video once again. Catch you on the next one, and subscribe if you haven't subscribed.